Hi students, welcome back again to this course, an introduction to mechanical engineering. I am Professor Yao. Element 4, Materials and Stresses. Keywords. As one of their responsibility, in a reliable and safe manner, when fully loaded, is parked on the ground. The landing gear creates an upward lift force. Family-sized automobile sedans encounter rough weather, bend up and down, is buffeted by turbulence. Take into account to meet the design's requirements. Element 4, Materials and Stresses. By applying the properties of forces system, mechanical engineers have seen how to calculate the magnitude and direction of forces that act on certain structures and machines. Knowing those forces alone, however, is not enough information for an engineer to decide whether a certain pieces of hardware will be strong enough or not fail in the task at hand. By fail or failure, we not only mean that the hardware will not break, but also that it will not stretch and or bend so much as to become significantly distorted. A mechanical component to break, stretch, or bend depend on not only the forces that are applied to it, but also on its dimension and the properties of material from which it is made. Those considerations give risk to the concept of stress as a measure of the intensity of a force that is applied over the certain area. Conversely, the strength of a material describes its ability to support and withstand the stress that is being applied to it. Engineers compare the stress that is present in a component to the strength of material in order to decide if the design is satisfactory. Engineers are able to combine their knowledge of force, materials, and dimension in order to learn from past failure and to improve and evolve the design of new hardware. In the discipline of solid mechanics, tensions, compressions, and shear stress are quantities that engineers calculate when they relate it to dimensions of mechanical components to the force acting on it. Those stresses are then compared to the material's physical properties in order to determine whether or not failure is expected to occur. When the strength exceeds the stress that is present, we expect that the structure of machine component will be able to carry the forces without damage occurring. Engineers conduct this type of forces, stress, materials, and failure analysis while they design products. Poisson contraction. The keywords: stress, tension and compression, a round rod at its left end, on right end, cross-section area, round rods, bolt and shafts, a caliper gauge, Poisson's contraction, shrink. The type of stresses that is more readily visualized and useful for you to develop intuition about materials and stresses is called tension and compression. A round rod that is built in and held fixed at its left end, and then later pressed in tension by force F that pulls on the right end. Before the force is applied, the rod has original length L, diameter D, and a cross-sectional area A. Engineers usually calculate the cross-sectional area of round rods, bolt, and shaft in terms of their diameter rather their radius R, since it's more practical to measure the diameter of a shaft using the caliper gauges. As the force F is gradually applied, the rod stretched along its length by the amount delta L. Poisson's contraction. In addition, the diameter of the rod shrinks by a small amount due to an effect known as Poisson's contraction. In many events, the change in diameter, delta D, is smaller and usually less noticeable than the lengthwise stretch, delta L. Homework. Handwriting all keywords and submitting them to Course Facebook. Just do the online quiz and see you next time.